Okay, today's lesson is about inverse functions. The little notes at the top here say they undo each other. The x and y switch, the domain and range switch, and the input-output switch. They reflect across the line y equals x. The inverse of every function is not a function. Okay, that's something to keep in mind. Sometimes it is and sometimes it isn't. Okay, the original function must pass the horizontal line test and be 1-to-1 in order for the inverse to be a function. So it has a horizontal line and a vertical line test. We'll talk about those as we go through the lesson. We can restrict the domain of a function so that the inverse will be a function. And this is composition. When I do f of g of x or g of f of x, and they both equal x, that's a key point, guys, not 0, not each other. They have to equal x. It means that they're inverses of each other. And we're going to get to that in the notes today, too. Okay? The first thing this one asks you to do is sketch the inverse of a function. What I like to do is find the ordered pairs. So this is -3, 1.5, and this point is 2, -1. So when I graph its inverse, you change that to 1.5, comma, -3, and -1, 2. So I go over here to 1.5, -3, which is down here, and I go to -1, +2, which is up here, and this is the line. Okay? This one, that point is, we gotta go back to blue, sorry, is 2, 4. I have 4, 0, and 6, 4. When I go to do the inverse, you have 4, 2, 0, 4, and 4, 6. So I'm going to do 0, 4 first, then I'm going to do 4, 2, and 4, 6, and I have a curve that's going like this. All right? Now I know they gave us this grid over here to use, but I didn't use it because I wanted them on the same line because of this. They reflect across the y equals x line. So if I come in here and put the y equals x line like that, those two graphs, if you fold it in half along that dotted line, they should end up on top of each other. This line ends up here, that one ends up here. Okay? This point ends up there. That's how you know they're inverses. Okay? Now, on this particular problem, the inverse, the green line, is not a function. Look, if I do a vertical line test, it crossed it twice. All right? So that's where it's talking about it's not necessarily a function. And the way you test that is if you do a horizontal line on the parent graph. So let's come over here. Here's my parent graph. If I do a horizontal line across there and it crosses twice, it's not 1-to-1. So its inverse will not be a function. It says we can restrict the domain of the function so the inverse will be a function. So in this case, I could restrict my domain and make my parabola only go from here to here. When I do the inverse, it would go from here to here, and it would be a function. Okay? Restricted the domain. We're going to talk about that more when we scroll down and do the rest of these problems. But that was the first thing. Okay? It asked you, is the inverse a function? We said no. I did the horizontal line test, and it wasn't. In order to make it a function, I would restrict the domain. All right. Each of these following ones, it says state the domain and range of the original function, describe any restrictions to the domain so the inverse will be a function, find the inverse, state the domain and range of the inverse, and sketch both. Well, I like to sketch first. So let's go back to blue. Intercept -4, slope of 2, up 2 over 1, up 2 over 1. So here's my line. It goes through this point, 0, -4. It goes to this point, 2, 0. All right, what's the domain? It's all reals. Are there any restrictions for the no restrictions? C, find the inverse function. Remember to do inverse, you switch your x and y's. So I have x equals 2y minus 4. Add 4 to both sides. divide by 2. You can leave the function like that. It's fine, okay? So I'm going to write the notation, though, as f inverse of x is equal to x plus 4 over 2. This is important. Note the notation for inverse. And what's its domain? It's all reals also. If you change that, you could write that as 1/2 x plus 2. So it goes through 2. Let's change colors. 1, 2. The slope is 1/2, up 1 over 2, up 1 over 2. And the line's going to go like this. We come back and draw the 45-degree line. Sure enough, it folds in half over that 45-degree line. All right? Next thing it asks us to do is use composition. So I have to put this one into that. They want me to call the inverse g. So g of x is equal to 1/2 x plus 2. If I do composition, I have to put that into my original function. So f of g of x equals 2 times 1/2 x plus 2 minus 4, which is x plus 4 minus 4, which equals x. And then I have to do the next one. I have to do g of f of x. And so I put this one into here. So I have 1/2 times 2x minus 4 plus 2. When you distribute, you get x minus 2 plus 2 equals x. And since this equals x and this equals x, they're inverses of each other. All right? Okay. Problem number 2. It's a parabola. It went left 2, 1, 2. That's right, sorry. 1, 2, and down 5. 1, 2, 3, 4, 5. So here he is. If I plug in 0, you get 4 minus, so it's negative 1. And you plug, so here's my parabola. Okay? What's its domain? That's the first thing it asks you. It's all reals. What's part B? It says, describe any restrictions to the original domain so the inverse will be a function. Okay, so I'm going to restrict my domain. I'm going to ignore this side of my parabola so that it passes the horizontal line test. It'll only cross once. Okay, so my domain is now going to be from negative 2 to infinity. It asked me to find the inverse, so I have x equals y plus 2 squared minus 5. You get x plus 5 equals y plus 2 squared. Take the square root. And then you subtract 2, so you get the square root of x plus 5 minus 2. So inverse, that's the notation, remember, to the negative 1, is the square root of x plus 5 minus 2. And they ask you for the domain of this one. Well, the range here goes from negative 5 to infinity, so this one's going to go from negative 5 to infinity. Okay, they flip-flop. Domain and range is flip-flop. Keep that in mind. Okay, the blue one, let's go get me my blue pen. Its domain is negative 2 to infinity. Its range is negative 5 to infinity. My pink graph, the domain is going to be negative 5 to infinity. And the range is negative 2 to infinity. Its graph, let's see, if this was negative 2, 5, we need to go to negative 5, negative 2. And it's going to go like that. Let's get rid of this, oh, that line there. Hang on, we'll put the blue one back. Okay. If I draw my 45-degree line, it goes right down the middle. Okay, they didn't ask us to do fog and goff on this one, so let's hold off on that. We had enough to do. All right, now, rational functions. Make sure you do these. Don't skip them because they're hard. All right, Don't skip rational functions because they're hard. What's the domain? Well, asymptote at 3. 1, 2, 3. Horizontal asymptote is at 2. Rational function, you've got to remember those. It's been a while. My graph is going to do this, and it's going to do this. Okay? Its domain is negative infinity to 3, and 3 to infinity. Oops, sorry. And its range is negative infinity to 2, and 2 to infinity. Do I need to restrict it? None. The inverse, this is a little tricky, okay? So you switch your x and y. So you get x equals 2y plus 1 over y minus 3. I'm going to multiply both sides by y minus 3. And I have xy minus 3x equals 2y plus 1. I'm going to put the terms with y on one side and the ones with x's on the other. So I'm going to subtract this, so I get xy minus 2y equals 1 plus 3x. Factor out your y and you get x minus 2. Now divide by x minus 2. And you end up with your inverse function is equal to 1 plus 3x over x minus 2. And its domain should be this. Yep, 2 is a vertical asymptote. Okay, so the domain of my inverse is negative infinity to 2 and 2 to infinity. Okay, this is the last example. I love it. Okay, it's a cubic function. Question, is our cubic functions continuous? Yes. So their domain is all reals. All right. Now, it's a tough one to graph. I believe it goes like this. Okay. We don't need any restrictions. We got to change this one again. So let's go down. Oh, that's okay. We'll find room. X equals y minus 1 cubed over 4 plus 2. Subtract 2 first. Now multiply by 4. You get 4x minus 8 equals y minus 1 cubed. Take the cube root of 4x minus 8 equals y minus 1, and then you add 1. So my inverse function becomes the cube root of 4x minus 8 plus 1. That goes up here. And its domain is going to be all reals. Now this is one where they're going to ask us to do composition. All right, so I have to put this into that. Blech. All right, so what do we have? You're going to replace this with cube root of 4x minus 8 plus 1 minus 1 cubed over 4. What's that left over there? Plus 2. Okay, so let's see, they wanted to call this k. So we have j of k of x. Clean it up. This one and that one are going to go away. So I'm taking the cube root of 4x minus 8 cubed over 4 plus 2. You cube a cube root, you get 4x minus 8 over 4 plus 2, which is x minus 2 plus 2, which equals x. Phew, I'm glad I did my algebra correct. Let's do it in reverse. I have to put that in here. So I have k of j of x. So I've got the cube root, 4. And in place of that, I have to put x minus 1 cubed over 4. Isn't it the plus 2 is in there. Oh, so this, hang on, we got to get rid of this. It goes here. So what am I doing? So I'm at that mess in there, and then I still have to add a -8, and then there's a +1. Ooh, lordy. So when you multiply by 4, these guys cross out. So I've got the cube root of x minus 1 cubed. I distribute here. You get +8, -8, +1. These 8's go away. You take the cube root of a cube, and you get x minus 1 plus 1. That happens to equal x. Thank goodness. Okay? Don't let the algebra scare you off. But that's all there is to inverses. Okay? Hope it made sense. Ask me questions.